In December of 2018, I began 3D printing CAD files from home that we were receiving from our vendors for a melamine program. These prints turned out to be very helpful in visualizing what the final product would look like. In June of 2019, Amscan purchased its first 3D printer, followed quickly by a second printer in August. The basic process in creating a 3D print is either to create the model in-house using 3D software or get a CAD file from our vendor. Because we choose not to let the printers run unsupervised overnight, our prints are limited by what we can print in a day's time. As an example, this platter model is subdivided a number of times until we get a model that can be easily printed in a few hours. Once the model is saved, it's loaded into a program called Cura, where a number of parameters are set to make the model printable. This includes orienting the model to get the best detail and adding support material if needed. Cura creates a file called G-code that will tell the printer exactly how to recreate the digital model layer by layer. Once the model is set up, it's saved to a Dropbox folder and transferred to the printer where it begins to print. Print is built up in a series of very small layers of extruded plastic. The plastic comes in reels of filament that are fed into the print head, melted and extruded in a series of very thin layers. Seen here, one printer is printing a portion of a platter, while the other printer is printing a portion of a bowl. Both pieces feature a bumpy texture. These prints are compared, allowing us to see that the scale of the texture was different on each piece, allowing us to go back to the vendor for changes. In addition to gray filaments, other filaments can be used to recreate glossy metallic surfaces, or even surfaces like soft rubber or wood. A lot of test prints were used to check the accuracy of each 3D printer. Everything from tall cylinders to little boat models called 3D benchies were used to test how well each printer can recreate a number of challenging surfaces.